Okay, we are getting into the standard normal distribution. Probably one of the most popular, most important distributions that you will learn in this class. So notice that we have the notation that suppose that a x is normally distributed, a random variable that's approximately normal with a mean of mu and a standard deviation of sigma. Again, these are population parameters, mu and sigma. And so we're going to be calculating a z-score here. This is the whole heart of it. So basically what you're doing is no matter what your data set looks like, let's say you have a data set where you are calculating the miles per gallon for a particular model of car. Okay. Those may range from, I don't know, 10 to 30 and collect the data on them. Okay, so then maybe we're looking at the number of ounces that a factory fills in a supposedly a 16-ounce bottle of, let's say, cola. So your values may range from 15.07 ounces to 16.2. So what this does is it takes those values, no matter what the data looks like, and it standardizes it into a standard normal distribution with a mean of 0 and a standard deviation of 1. And then we can use the properties of the standard normal distribution to find probabilities based on that. And that involves z-scores as well. So the z-score is going to be x minus mu over sigma. I want to show you what a standard normal curve looks like. Again, you know, you're giving your data, and it's not telling what the data looks like. But when you standardize it down, this is what your standard normal curve looks like. It's going to be a bell-shaped curve. I didn't do a very good job of doing that. And it is symmetric about your mean, which is going to be 0. And your standard deviations, which are, so we're going to have 1, 2, and basically 3, and then you'll have them here, and these are z-scores, by the way, -1, -2, and -3. Okay. Now, essentially, I think the empirical rule, which it mentions briefly, maybe in your book, which we're not going to go into because we're going to be actually calculating these, that 99.7% of your data is going to fall between 3 standard deviations. Should have put a negative on there, of the standard normal curve. Okay, so a z-score of 1 means that it is 1 standard deviation away from the mean. A z-score 2 means it's 2 standard deviations away from the mean, to the right of it, by the way, I should say, and 3. And then a z-score of -1 means that that value that you're calculating for x is 1 standard deviation to the left of the mean. And then 2, which would be 2 to the left, and 3, and so on and so forth. And the total area, now if you just recall, theoretically, these actually never touch the number line. The total area under this curve is 1. If I was to shade it all, and just again, between here and here, we're looking at 99.7%. And those correspond to probability. So let's just kind of look here what we're given and look at this example. So we're given that we're a normal distribution. I'm given that mu is equal to 6. I'm given that sigma is equal to 1.2. So what is the z-score associated with x equals 7? So I want to find this. So z is equal to x minus mu over sigma. So the z-score with x equals 7, I just simply substitute in where x is. I put a 7. Subtract off mu, which is 6 in this problem. Divide by the standard deviation, which was again given 1.2. Okay. 6 equals, or enter divided by 1.2. Right. 0.8333. I'm just going to do 4 decimal places. Now, when I was in school in the 80s, we had to use tables to calculate probabilities. We're going to be using technology to do that. We'll be using StatDisk and your TI. But Z-scores are normally rounded to 2 decimal places. And this particular problem is asking you to round it to 3. So, 0.833 here. Again, remember my alpha math is kind of picky. Now, what value is associated with z equal 1.1? Okay, let's go up here. I should have put an 8 on this. Well, I'm just going to write the x minus mu over sigma. And I'm getting the z-score. Okay, so I'm going to substitute in, just like in algebra. 1.1 is going to be, I don't know what x is. Know what mu is. I know what sigma is. Okay. So this is what's called a proportion in algebra. So we're going to just cross multiply. So I'll rewrite this as 1.1 times 1.2 is going to be equal to the x minus 6 times 1. There. X minus 6 times 1 is 6. So let's do the left hand side. 1.1 times 1.2. Okay, so that gives me that 1.32 is equal to x minus 6. And we know from algebra we just add 6 to both sides. I'll just simply say plus 6. And that's going to be equal to 7.32. Now notice it's asking for 3 decimal places, and we actually come out to 7.2. And I think we have figured out in the other examples that my alpha math is not making you pad these numbers. Okay. What value is 2 standard deviations to the right of the mean? Okay. So to the right of the mean, that means that my z-score is 2. Okay. If I was looking to the left of the mean, that means my z-score is negative 2. So I think, let's see if I can kind of just do this over here on the side so you can still see this. So what value is 2? And again, this is going to be an x value, and you see x equals. So I've got my formula here. So the z-score is 2. So, and this is C. So let me put C up here. So 2 is equal to x minus mu, in this case is, again, 6 over 1.2. We're going to cross multiply 2 times 1.2. Think of that being over 1. Is equal to 1 times x minus 6. Okay. So let's do the 2 times 1.2. So 2.4 is equal to x minus 6. So we add 6 to both sides. I just simply do that. That's 6. So x will be equal to 8.4. So let's put this in here. And again, it says 3 decimal places is needed. So let's look, see what we get. that all correct? Let me know if you have any questions. Thanks.